Welcome, welcome to online classes, e-learning classes for Junior Secondary School 2, Mathematics. Topic of today, angles between lines. Made possible by St. Anthony International School. All right, Excel, welcome to today's class. Today we'll be talking about angles between lines. And the subject you're
Okay,
going to be
sir.
taking today is mathematics. As you have on your screen, Mathematics for Junior Secondary School, topic of today, angles between lines. B, first to know what angles between lines are actually, what they actually mean. That will be finding the angle between two lines using a formula, which is the goal of this lesson. And also,
Okay, sir.
when two lines intersect in a plane, their intersection forms two pairs of opposite angles called vertical angles. Now, if the two lines are not perpendicular and have slopes M1 and M2, then you can use the following formula to find the angles between
Okay, sir.
lines. So today, I'll be showing you how to find angles between two lines where you have M1 and M2. Now let's look at a diagram to buttress this point. The formula for finding angles between two lines is known as tan theta is equals to M2 minus M1 all over 1 plus M1 multiplied by M2 all bracket square. Can you write that down?
Okay, sir.
There's two mass.
Waiting, sir.
Can you also see the diagram that you have beside there? Can you draw it?
Yes, sir. Okay, sir.
Yeah, draw the diagram you have there.
Okay, sir.
Now you will notice that you have theta 1, theta 1 and theta 2. And if you look very closely, you will notice that what you are seeing on the screen is more or less like a graph sheet. You have the y-axis, this one here that is going down.
Yes,
You have
sir.
the x-axis.
And the x-axis.
Good. Now you also have a line that is cutting through the x-axis and the y-axis, right? And then you have one that is just cutting only the x-axis.
Yes, sir.
Good. Now, if you look at that diagram, you'll notice that there's an angle theta that is formed at the top of the triangle. And there's also an angle that is formed inside the triangle.
Yes, sir.
Which is the one that is named theta 1. Then you also have another one that is formed outside the triangle, which is known as theta 2. Now, if you look closely, you'll notice that theta and theta 1 are both acute angles. You know what acute angles are? Angles between 0 and 90 degrees, right?
Yes, sir.
Good. And if you also look at theta 2, you notice that theta 2 is actually looking like an obtuse angle. But I think it's an acute angle from this particular perspective. Right or wrong?
Right, sir.
Okay, good. So, with this analogy, we will now look at the following. How to derive the formula to find the measure of the angles between the two lines. This is how they derive this formula that is here. Tan theta is equals to M2 minus M1 all over 1 plus M1 over M2. How it was derived is what we want to look at. Okay? So, looking at how it was derived, first of all, first, notice that when two lines intersect, one of the two pairs is acute and the other pair is obtuse, right? Good. The angle between two lines is defined as the smallest of these angles, or the acute angle denoted by theta. So if you look at this, you notice what I just said before. The one that is written theta, up here is actually an acute angle. This is also an acute angle theta 1, and this looks like an obtuse angle. All right. We are going to use the inclinations of the two lines to find the angle between those two lines. Do you understand it up to this point?
No, sir.
If you do not understand, you can ask me a question, which is more reason why I can see your face and you can also see my face. Do you understand that?
Okay, sir. My question is from here.
Okay.
Yes, sir.
What don't you understand about this particular? Is this particular slide you are seeing on your screen that you're talking about?
No, the other one.
Okay.
Of the
What would the diagram?
where you said that yes.
Good.
Where you said that one look like an acute but not an acute because an obstruction.
Okay. If you look at that diagram I have on my screen right now, I said you will notice that two of the theta angles are actually acute, which is an angle between 0 and 90 degrees, right? Good. Now, sometimes from this formula, it says that two of the angles you have are supposedly to be acute, and one is meant to be obtuse. But this diagram you're having on my screen right now, theta 2 is looking more like an acute angle. That's what I'm just trying to explain to you, but it's actually an obtuse angle. Do you now get what I'm saying?
Yes, sir.
Good. So can we move ahead?
Yes, sir.
Have you written the formula down? Tan theta is equals to open bracket m2 minus m1.
Yes, sir. I've written it down.
Okay, good. All right. So, like we said, from this, we said we are going to use the inclination of the two lines to find the angles between the two lines. This was what we said. All right. So we said we are going to use the inclination of the two lines to find the angles between the two lines. Now, second, we need to show that theta is equals to theta 2 minus theta 1. So theta here, the angle which you can see, theta here, the angle which you can see is equals to theta 2 minus theta 1. Now, using the triangle ABC, like what you have on your screen, can you see what we have on your screen?
Yes, sir.
Good. Using triangle ABC, we know that the sum of the angles in that triangle is equals to 180 degrees, right? Naturally. Sum of angles in a triangle is 180 degrees, right?
Yes, sir.
Good. Now, so we can safely say that theta, this one that is here, can you see my mouse actually moving?
Yes, I can.
Good. So this theta that is up here beside the B plus theta 1 here that is beside the A plus X, all these ones that are inside the triangle. All of them, you equate them to 180 degrees. Godwin, welcome. I would need you to start copying this down.
Thank you, sir.
I'll need you to start copying this down. Maybe towards the end of the lecture, I'll reiterate and then you understand what we are talking about. But the topic for today is actually angles between two lines. And we have a formula in which we'll use to find angles between two lines. Let me just quickly finish explaining this and I will show you the formula for this particular topic. So as I was saying, furthermore, x plus theta 2 will be equals to 180 degrees. That will now be equation 2. So you have equation 1 and you have equation 2. Now, since x and theta 2 form a straight line, that is the one down here, x and theta 2, if you can see my cursor, you will see this place I'm trying to circle here with my cursor, x and theta 2, where there is C. Where you have C, you have x there and you have theta 2. So since these ones form a straight line, you know that they say angle on a straight line is 180 degrees, right?
Yes, sir.
So that forms equation.
Yes, sir.
Now, I will now replace 180 with x plus theta 2 in equation 1. So watch what I'm going to be doing. Watch what I'm going to be doing. I'm going to be bringing up another slide, a whiteboard. Can you see this whiteboard? Excel, can you see this whiteboard?
Yes, sir, I can.
Yes, sir.
Good. Now,
Yes, sir.
yes, I heard that. Let me move this a little bit further down so that you can see what I want to do. So now I have theta plus theta 1 plus x equals 180. Students, can you see what I'm writing on my screen?
Yes, sir.
So this is equation
Yes, sir.
1. Then I also have x
Yes, sir.
plus theta 2 equals 180 equation 2. Now, this that I have done is for you to understand what I'm trying to do. I'm trying to derive the formula. I'm trying to derive the formula that was used for this particular explanation. Can you still see?
Okay, sir.
Okay, good. I want to put it side by side. Okay. Excel, can you see both the PowerPoint and the whiteboard? Godwin, can you see the PowerPoint and the whiteboard side by side?
Yes, sir.
Good.
Yes, sir. Yes, sir.
So in this particular position, what I'm going to do now is that I will replace this equation 2 in equation 1. That's just what I want to do. When I mean replace, what am I saying? I will now say that theta plus theta 1 plus x equals to x plus theta 2. Do you know what I mean when I say I will use equation 2 to replace, I'll use equation 2, I'll replace equation 2 in equation 1.
Yes, sir.
Do you understand it up to this place? Then, moving ahead, what we will now do
Yes, sir.
is
Yes,
that
sir.
we will now subtract x from both sides. Subtract x from both sides. So subtract x from both sides. Now, if you're subtracting x from both sides, simply means that you are going to have to write theta plus theta 1 plus x. Then you now put minus x. You now come to the other side too. You now do the same thing. X minus x plus theta 2. Do we get this? Now, if I do this, that simply means that this one, this x plus x and minus x will remove each other, Abby? Then this one too will remove each other, is it not? And after doing
Yes, sir.
that, I will now have theta plus theta 1 equals theta 2. Right? Excel.
Yes,
Yes,
sir.
sir.
You can see what I did. You can see what I'm doing, right?
Yes, sir.
So I want you to understand it. This is how the formula was derived. So
Yes, sir.
I am getting to the formula. Now, what I will do is I will now subtract theta 1 from both sides. How do I subtract theta 1 from both sides? I'll come here. subtract subtract theta 1 from both sides. So if I do that, I will have
Already back.
welcome back. Sorry, I had to go off for a few minutes. I needed to take care of something off the wall. All right. So looking at what we are doing,
Okay, sir.
looking at what we are doing earlier.
This involves checking all machines to ensure that they are in good condition before setting them for use. You must check the machine, ensure the machine, ensure they are in good condition before setting them. Yes, you cannot do everybody is announced. Before you take your car out, you must check if your car.
All right. So we were actually at a point where we are subtracting theta from both sides. So if we subtracted theta from both sides, that's theta 1 from both sides, we should have theta plus theta 1 minus theta 1 equals theta 2 minus theta 1. So we have this. Now, if we subtract this naturally, you know that you can do this. You can actually subtract this. Who is writing on my word? Hello?
Sir.
Oluchi, stop writing on my.
No.
Okay. So we have this will cancel this, and then we will have theta to be equals to theta 2 minus theta 1. So theta can be equals to this. Now, you can use the formula for the tangent of the difference of two angles. Now, what is the tangent of the difference of two angles? It is known as what? Tan theta will now be equals to what? Tan. Do you have a question? Do you have a question? Oluchi, Excel, do you have a question?
No, sir.
Okay, you understand what I've written on the whiteboard, right? Godwin.
Yes, sir.
Godwin,
Yes,
are you
sir.
following? Okay, good. So with
Yes, I'm
this,
following, sir.
with this, you can easily bring out the formula from the tangent of the formula known as tangent of difference of two angles. So from the formula known as tangent of difference of two angles, if you replace what you have there, you will now have you now have tan theta equals to tan theta 2 tan theta 2 minus tan
Okay, sir.
1 all over, sorry for that, all over 1 plus tan theta 1 multiplied by tan theta 2. Do you get this? Now, what I've just simply done
Yes, sir.
is to derive the formula
Yes, sir.
for finding the angles between two lines. So from this formula, what we will now do is that we will now relate it to the inclination of a line, where we've already understood that tan theta is the same thing as m. So once you understand that that is that, you can simply say that inclination.
Hello.
You look at it from the inclination of the line, okay? The reason why I'm writing it there is so that you don't mix it up.
Okay, sir.
So looking at the inclination of the line, we already understand that tan theta is equals to m. And once we understand it, all we just simply do is that we substitute m wherever you have tan theta. So if I substitute m for wherever I have tan theta, good. So replace wherever you have tan theta with m. If you do that, then we will have the formula for the angles of a line, which will be looking like this. Which will be looking like this. I'm trying to replace tan theta now with m. If I'm replacing tan theta with m, what I will have as my formula now will be tan theta is equals to, replace it with m, my m2 there, I will have m2 minus m1 all over 1 plus m1 multiplied by m2. So this is the formula we will now use to find the angle between two lines. Oluchi, do you get that? Do you now understand how the formula was derived? Because the first thing we did was to understand how the formula was
Yes, sir.
derived. Good. Now that we've understood how the formula was derived, let's now go to some questions. Thank you for participating in this class. In our next class, we will be taking some examples. Feel free to follow us on all our social media handles. Thank you.